All right. I think we're ready to get started here. Welcome in, everybody. I think everything looks right. Let's see. Am I getting an echo over here? No. Okay, good. Okay. So welcome on in. So kind of an important week. So we want to make sure everyone knows what they're supposed to do, because if not, it's going to end up hurting your grade. So let's sort of discuss that stuff. And thanks to everyone throwing their name in the chat. That'll help when I take roll in a few minutes. Okay, so let's see, make sure I'm pressing the right tabs here. Okay, so I have, sorry, I was all set to go, and then at 1 minute before class was supposed to start, my dentist called. So now got me all lost track of everything I was going to say. So in Delta Math, you've got your practice exam, right, which is a fairly large assignment. It covers all the algebra for the entire semester. It's due April 3rd. Now, I wouldn't wait till April 3rd to do it at all. I also have written and assigned the actual exam. Okay, so the actual exam is similar to stuff on here. It is significantly shorter than this, so don't panic if this seems like a long assignment. This is a very long assignment, but you also have like 3 weeks to do it, or had 3 weeks to do the practice test. The actual exam should be doable. Many of you will do it in an hour. Some of you will do it in a little over an hour, and I think I gave you 5 hours to do it. So from the time once you start the actual exam, it's on Delta Math, so you'll see it on Delta Math. Once you begin the exam, you have, I think, 5 hours to finish it. So don't start it right before you go to work and then go, oh, well, I'll finish it when I get home. You might not be able to, okay? And I believe it's also due April 3rd. So it's like right before we come back, right? So don't forget to do it. I mean, that's a long time. It's hard to justify extending it past that. If you go, oh, I forgot to do it, don't forget to do it. Just do the assignment, do the test, okay? There is a retake, and then you're going to end up having, but that gives you one shot at the test rather than two. If you miss the first test and you just do the retake, that means you're only getting the second shot. And it would be really good to not have to do the retake, because today we're wrapping up the algebra for the course. That means when we come back from break, you're just going to be dealing with the math for meds portion, the nursing and paramedic and that kind of stuff that you need to know, which most students they find it preferable, because first of all, it's not the brutal algebra that we've been doing. The algebra is a little more straightforward, but also it's more in line with your actual educational goals, right? If you're going to become a nurse or a paramedic or whatever it is that you're doing, this is in line with those things. So most people find that part of the course a little more enjoyable, is the feedback that I'm getting. So you don't want to also still be working on algebra from previous to spring break, right? So make sure you take the exam, really try to do a good job on it. If you do poorly on the exam, that's okay. There will be a retake, but you definitely want to try to avoid having to take that retake exam, okay? The actual exam is shorter, but it does cover a little bit of everything. It's got stuff from the chapter on roots, square roots and stuff like that. It's got systems of equations. It's got factoring, solving equations. All those kinds of things that are here in the practice test that we've been going over are in there. There's just less problems. There are not this many problems that are in there. Okay, this is a lot of problems for this practice test. So, and then let's see, what did I do? So we've got didn't I add that? Oops, where's the thing I added? Oh, right. And then I've got the practice exam 1 questions and answers tab. So this is a place for you to go and give each other questions and answers. So some of you already been doing that. That's great. Helping each other out with the practice test, helping each other figure out how stuff works. This is a graded assignment. So everyone that leaves a meaningful post in here, right? So I haven't read through all of these, but looking at them so far, it looks like people making, legitimate comments. They're not just saying oh, good job, or, something that doesn't have anything to do with the topic. They're honestly and genuinely interacting with the discussion board in a way that is the way it was intended to be, everyone here will get 10 points, right? So I'll go through, I'll give you your 10 points out of 10, and you're good to go. So pretty easy points to get. Plus, it's helping you do well on the practice test, which is going to help you do well on the actual test. So don't forget to do that. That's also due April 3rd. Just do it now. Don't wait till April 3rd to do it. Just do it now. Get your points taken care of, and then you won't have to worry about, oh, I forgot, because this is not going to get extended, right? There's really no reason. You have until April 3rd. It's only going to take you 5 minutes to do. There's no reason to extend that. So make sure that you are aware of that there is a discussion there that's graded, and you get 10 points for it. Go in there, and then make use of it to help you do the test that you have to do anyways, and then get a better grade on the test. That's good. We'll have more of those discussion boards in the second half of the course coming up as we do these chapters down here. Okay, so there's the practice exam 1 discussion board, and then so I have it set on a timer so that, or technically not a timer, but a scheduled time. I've written the actual exam and I've scheduled it. I believe it will become available Wednesday night at 11:59, basically meaning that starting Thursday you can do the exam. Okay, now you can choose which day you do the exam, but please remember, once you start the exam, you have so many hours to get through it. Okay? And if there's anyone who gets accommodations, testing accommodations or anything like that, I don't think there was when I looked, contact me and I'll make sure that your accommodations are taken care of. Okay? It's part of how we do testing. So so contact me about that if it applies to you. And then yeah, that's kind of about it. I'm not going to go into like which topics are on there or which problems are not. You kind of need to know how to do all of that algebra, and then you'll see similar stuff on the test. I didn't try to make the test super hard or anything like that, but I did have to make sure that it shows whether you know how to do the material that we've covered, right? So I don't remember if there's like 15 or 20 test problems or something like that on the test, but it's significantly shorter than this practice test that you've been taking. But if you know how to do the problems on the practice test, you should be good to go for the actual exam. Okay? So before I get started on talking about stuff, is there any questions or comments or concerns that anybody has that you want to ask now while you have the opportunity?
Yeah, I had a question. I know you said the exam would become available Wednesday night, so basically Thursday of this week. When is it actually due? Like, when's the last possible day you can turn it in?
I think it's due April 3rd at 11:59. It'll show you when it becomes available, but I think I kind of gave you all of spring break because I know everyone's going to be doing things differently over spring break, so I'm giving you like maximum flexibility that I can in order to you can, if you want to do it before you go do spring break and then you don't have to think about it, do it that way. If you want to study over spring break and then take it right at the end, do it that way. It's whatever way you think you're going to do the best. But then my goal is when we come back, I'll mention a few things about retakes and stuff like that, but then we got to dive into the new material and get all that taken care of. And to the question in chat, both the practice test and the actual test are in Delta Math. So that's where you will take those two assignments, is in the Delta Math. And then we'll come back. We'll get everyone set up on the Math for Meds. And I think that should all be ready to go. And there shouldn't be any trip ups when we get going on that. And we should be all good to go. So that's the idea there. Any other questions or concerns? No, we're good. Okay, well, if more questions pop up, we can look at those. Otherwise, I will get into finishing up the material. This is actually the problem we ended with last time. So we'll be talking. I'll do a couple more problems on log properties, and then we're going to get into logarithmic equations, solving exponential and logarithmic equations, and then that's kind of it. That's the algebra. That's all the algebra that you need to know for the course that we're required to cover, and then we'll talk about stuff from when we come back, it'll be math for meds. So remember these. We looked at things like if you take the log of the product of two inputs, it becomes the sum of the output of the logs. Right? It becomes the sum of the output. We have a power rule about, let's see. Oh, this was our definition, though. We have our basic definition of the logarithm. So we have a few different properties that we looked at, and interpreting the logarithm. You need to do all of those kinds of things. So basically, we looked at the separate log properties separately, and there's videos on Canvas about each of those, about doing each of those. In fact, let's take a look at that. So if we go to, where is it? Properties of logarithms. So I've got videos here that show each of the log properties individually. Okay, now that's great because then you can just kind of focus on a simple problem of that one individual log property. But then what happens is you start getting into problems that involve multiple log properties at a time, and I see some students getting confused with these. So that's why I want to go over those, because it's usually a matter of students overthinking the problem rather than progressing through it. They're asking so many questions about how to progress through it that they kind of put themselves in like a locked state. Okay, so let's take a look here. So the problem I want to look at is, where was it? Oops. Wow, that's weird. It's not resizing. It's making it bigger, but it's not. That's weird. Usually, usually it will wrap around the line. That's weird. Let's do this then. Let me end. This part. There we go. That's a little better. In fact, let me put this on a different line. Okay, that looks better. Little easier to see now. Okay, so here's what we have is a situation where we are going to want to do what they call compressing logarithms. So when it comes to simplifying, there's two things you can do. You can expand logarithms or you can compress logarithms. And one of the things we'll be using is, for instance, the rules that we looked at last time and that there's the videos for in Canvas, which are the rules that we use for logarithms. Now, a lot of times when we give you a formula in mathematics, you pretty much always use that formula the same way, right? You start on, say, the left and you move to the right. But with logarithms, we go both directions. So you'll have problems where they give you something like on the left and they say, like this right here that I'm showing with the cursor, and they say, like this part right here, they might say expand this logarithm. So then the way you're going to use this rule is you take what's on the left and you turn it into what's on the right. Okay, so you're moving from left to right using this formula. Now, other times they're going to start with what's on the right and say compress the logarithm, in which case then you're going to turn this into what's on the left. So this equation works both ways. It's a formula that you can turn around and go either direction, and you will for the homework. So make sure that you can start on the left and move to the right, or you can start on the right and move to the left. And then we have the other log rules that are listed here in the videos to watch that are on Canvas that are our other log rules, and I'll be sort of referring back to these regularly. In fact, I probably should write them so that we have them, so that I can refer to them regularly. So let's get rid of this problem and make this log base b of then we had one that was the power rule. So these are the three big rules that we have. So when you want to get comfortable with these, so whenever you see one of these 6 pieces up here, both sides of the 3 equations, you want to at least be able to recognize like, oh, well, I could make this change if I wanted to. Sometimes it might help you, sometimes it might not, but at least you can recognize when you can use these rules. So this says if you have an input into your logarithm that is a product, you can split that up into the sum of 2 logs. Going the other way, if you have the sum of 2 logs with the same base, you can simplify it into a single log that is the product of the inputs. Similarly, we take one that's for division of inputs and it becomes the subtraction of the log. Okay? And then we have this power rule that says if we have the log of something to a power, that becomes r times the logarithm of that amount. Okay? So we've got these 3 things right here. These 3 are the basic rules that we use for properties of logarithms, and then we start putting them all together. So in this one, there's a lot of things we can do. Oops, I've got a typo here. This should look like that. Oops, in fact, it should look like that. Okay, so what do? I start looking at this, and then I think about those 3 properties we were just looking at. They're the ones, again, if you're kind of, it was a week ago and you're like, I don't really remember the properties, just think back to those videos that are on Canvas. And they're short, so if you need to watch them again, watch them again. That's okay. So in this case, they want us to simplify, and usually what they might say here, there's a couple different words they use, but they might say condense. Condense to a single logarithm, or sometimes they say simplify to a single logarithm. So then you know which direction. We're going the direction of compressing things down so that basically you shouldn't have, like, see how we have the word log showing up 3 times here? In the end, you want 1 log. You want it only written a single time. So what can we do? Well, when we have to compress logarithms and you have coefficients in front of your logarithms, that's generally the thing you're going to take care of first. So what we're going to do is use this rule right here about the power rule. So see how we have a value in front of the log? We're going to take this and we're going to move it into this where that r becomes a power on your input, right? You can't really use the other log rules until you have that one taken care of. So let's do that. Okay, so I'm going to take this 3 and move it to be the power on the input using this rule right here. Okay, so this would become log of x plus 1 cubed. So the 3 became an exponent. And then we've got minus the log of x plus 2 squared plus log x. Oops. Okay, so see what happened? All we did here is we took the coefficients that were in front and they became the exponent on the input of the logarithm. I did that for the first 2 terms. We don't have to do it for the 3rd term because we don't have a coefficient out there. And that was just using this right here. We started with something on that looked like this. That's the 3 and the 2 out front. So it's 3 times the log, 2 times the log. That's what we have here, r times the log. So we started with this, and then we moved it over to where it was m to the r. The r becomes the exponent. So we used this rule 2 times. This one right here got used twice. And that's all we've done so far. Okay, so, you know, a lot of times students get stuck on, like, I was talking about overthinking these problems. Students will, I'll see students stare at the problem and they're just trying to, like, do the whole thing in their head. They're like, well, I can't see it beginning to end. Right, you're not going to be able to. So all you do, like, this is what I do when I do these. I just look at it and go, do I see one step that I think I can do? Yeah, then I do it. And then you just kind of repeat that strategy. Do I see another step I can repeat? Yeah, okay, do that one. Do I see another one I can repeat? Yeah, then do that one. And you just keep doing that, and it should get a little bit simpler each time, and then all of a sudden you're at the end, and there's nothing more for you to do. But thinking you're going to be able to see all the steps that you have to do without writing them down, it's not going to work. Okay, so don't do it that way. So now what I'm going to look at is, all right, well, I've got 2 logs being subtracted, and I've got 2 logs being added. So what am I supposed to do? I'm trying to remember what I do with logs that are being added and subtracted. Oh, look, we have that right here in our 3 rules. This first one has 2 logs being added, and the second one has 2 logs being subtracted. So then we're going to use these accordingly. So first I'm going to take care of that subtraction that we have in our problem. So I'm going to go down and go, okay, well, I've got a subtraction right here. So what does that subtraction mean? It means that I'm supposed to write this as the quotient of our inputs and then only have a single log. Okay, so let's see what that's going to look like. So I'm going to take the log of the fraction, and the fraction's going to be, so it's the piece on top, the first piece over the piece on bottom. So we've got x plus 1 cubed and x plus 2 squared in the denominator. So in fact, I think this is looking a little weird. Why don't I get rid of these parentheses? That might actually make it look a little better. Except these ones take a little more time to typeset, sorry. There we go. Got it right this time. Okay, so see what we did? We took these 2 logs that were separated by a subtraction, and that becomes a single log where it's the first input over the second input. So it's just this rule right here, the second one. This is the rule I just applied here to this subtraction right here. So we turn the subtraction into a division of the inputs. Okay, so now I have to finish this line because we still have the plus log x part. Right, so what you see right there, that's the completion of our next step, right? Okay, so now I go, okay, but now I see what's going on. Now I have logs and they're the input. I have the sum of 2 logs right here, right? So if I look at the sum of logs, will I come up here? Oh, I have a formula for sum of logs. It's right here. That says I'm supposed to take the inputs into these logs and I make them a product of the input. Okay, so that means that down here, I'm going to multiply this thing by x. So basically what this piece becomes is just what it was, but with an x on top now, because we're multiplying those inputs. So this is what the final thing would look like. So that's what they mean condensed to a single logarithm. So we started off using the power rule, then we used the quotient rule, then we used the product rule, and now we're done. And it looks like a complicated problem, but we finished it. Not too bad. Okay. So that's how you just kind of put all those together. All right. No questions on how I did that? Makes sense? Okay. Well, then why don't this is probably a good time to take roll. So let me do that. Where's my pen? There it is. Okay, let's see who we got. Oops. Okay, great. Got that taken care of. Okay. So then what we are moving into is exponential and logarithmic equations. So that is equations that involve exponential and logarithmic expressions in them. Now, one thing that makes this a little bit more challenging is that most of the other topics that you've learned in algebra, when you learned how to solve an equation, there was usually like one way that you went with and sometimes two ways that you went with. But it's not quite as cut and dry with exponentials and logarithms. So for instance, when you wanted to solve a quadratic equation, you can use the quadratic formula. That works every single time. If you want to solve an equation that has square roots in it, we use the same procedure every time. The details came out slightly differently, but it was that same basic algorithm to solve square root equations. Rational equations, when we solve those, same basic steps in order to solve those equations we use every single time. Unfortunately, with exponentials and logarithms, it's not quite that simple in that there's like 4 or 5 different techniques that we have to keep in mind depending on the type of exponential or logarithmic equation that we are trying to solve. In other words, you can't just do the same thing every single time. You have to look at the problem and study it for a minute and go, okay, which of the 4 is this type of problem? And then once you figure out which one to do, then you apply that method to it. but that means you have to learn about 4 different methods, which, you know, it's not great, in order to get there. But don't worry, you'll get it. I'm not saying they're all terribly complicated, because they're not. If you know the steps, the stuff we've been learning so far, you'll be fine. But it's also not, it's not like easy either, right? It's kind of a combination. So let's take a, I'm going to do, oops, let me get myself situated so I can type here and see the book. So let's do some examples of what this is going to look like. So we want to solve, but we want to solve something that looks like 3 to the x plus 1 equals 81. So we want to solve this equation here. 3 to the x plus 1 equals 81. And it's like, it's kind of difficult because we go, well, I don't know, I'm supposed to solve for x, but x is up in the exponent. How am I supposed to solve for a variable that is up in the exponent? It's confusing, right? Like if I just said solve for x, you'd go, well, I'm not sure I can do that. It's a little bit tricky. So, and that's ultimately the thing that's tricky about exponentials and logarithms, is that the variable is in the exponent and it makes it harder to access. So that's a lot of what we have to deal with when we're doing these types of equations. So this particular equation is the easiest of the ones that we'll look at. What you want to recognize here is that both the left and right side of this equation can be written in terms of base 3. So that's what you always want to look at, and it's not always one of the bases that exists originally in your problem. It could be that both sides have to be rewritten. What you're looking for is, can I write both sides of this equation in terms of the same base? Okay, so the fact that we know that 81 is a power of 3 tells us that yes, I can do that. Okay, so 3 to the x plus 1 equals, okay, so how do I write 81 as a power of 3? So you go 3, 9, 27, 81. So 3 to the 4th. 3 to the 4th is 81, so 3 to the 4th. So do you see how I've written both sides of the equations in terms of base 3? Well, that's great when it works. In a few minutes, we're going to see examples where that does not work, but that's okay. When it works, we want to use this easier method. It's kind of like quadratic equations. You can solve any quadratic equation using the quadratic formula, but it's usually much easier to solve quadratic equations using factoring. So if you run across a problem that can be factored, well, then why wouldn't you just use factoring? It's easier. But we also have this backup of the quadratic formula that works for us every single time. We're going to learn a method in a few minutes that works every single time, but when this one does work, it's easier, right? So now what we do in this case, since 3 to the x plus 1 equals 3 to the 4th, we can set those inputs equal to each other. So what does that mean? We're setting the inputs equal to each other? Basically, set those exponents equal to each other. Now this only works when you can write both sides in terms of the same base. But in this one, I took the exponent on the left, set it equal to the exponent on the right. Now we have something that's easy to solve, right? X equals 3. Okay, so that's how we do that type of problem. Sorry, I was looking at the next problem I wanted to do, and it looked like there was a typo in the book. So, right, here's an example of another one. And as always, ask questions if you feel that you need to. All right, so you might look at this problem here and go, oh, that doesn't seem like the one we just did, right? 2 to the x squared plus 2x equals 1/2. How would I write that so that both sides have the same base? Well, 1/2 can be written as a power of 2 if you remember your negative exponents. This would actually become equals 2 to the, oops, I don't want to write it that way. I want to go negative 1. Right? 1/2 is the same as 2 to the negative 1. If you remember your rules of exponents, that's how that works. So we can rewrite it this way, and then now we go, oh, okay, so what do I do next? I set those exponents equal to each other. All right, so let's set my exponents equal to each other, just like we did in the previous problem. So that means we're going to be looking at x squared plus 2x equals negative 1. Okay. But now, so notice what's happened here. There's been a change. We went from dealing with exponential problems to now we're dealing with a polynomial problem. Okay? So now we can finish this out using the tools that we're already aware of. So x squared plus 2x, adding 1 to both sides gives us plus 1 equals 0 because we want to get 0 on the right side of the equation. And then we're going to use whatever method we can to solve this thing, either using factoring and the zero product principle or using the quadratic formula, whichever one we feel that we need to do in order to complete this problem. So let's see. I think I can factor that one, can I? So it's going to be what? X plus 1, x plus 1? Yeah. And in this case, we have a repeated solution. So when we set x plus 1 equal to 0, we get that x equals negative 1. And then we just ask ourselves if that makes sense or not. Oops. Okay, x equals negative 1. Let's see, if I plug that back into the original equation, I get what? 1 minus 2, which is negative 1. Yeah, that works out. So this is the correct answer. X equals negative 1. Okay. So that's how you do that type of problem. It's really just like this one up here, but it's slightly more complicated because, for one thing, the equation we ended up solving was a quadratic, but also we had to remember those rules of exponents in order to do the algebra right to even get to the point where we could solve it the way that we're used to, right? Let's see. There was one example I wanted to do here. Let me see if I can find it again. We'll see it later. We'll see it later. Okay, so yeah, for the sake of time, we should move on. So getting to the next type of problem. So this is what you want to look for when you do these problems is look for, can I write both sides of the equation in terms of the same base? If you cannot do that, then obviously you can't use that method. Okay? So what's the next ones look like? Okay, so this one's a little more straight, or this one will be a simpler problem to do, but I'm just kind of giving you an example at the beginning here. So see how this is different than the one we did a minute ago? This side cannot have both sides written in terms of the same base. You cannot cleanly write 5 as a power of 3. You cannot cleanly write 3 as a power of 5. So you can't, like up here, we were able to take the 1/2 and write it as 2 to the negative 1. Here we were able to take 81 and write it as 3 to the 4th. Down here, I can't turn 5 into a power of 3. I mean, we could, but not in a clean way, not in like an integer discrete way that would allow us to do it cleanly. It would be a big mess of like rounding, which we don't want. So what am I supposed to do here? How am I supposed to solve this? Well, remember I mentioned that the difficulty of solving exponential and logarithmic equations is when the variable is occurring in the exponent. When the variable occurs in the exponent, how am I supposed to get at it? How am I supposed to solve for that x there? 3 to the x equals 5. How do I solve for x? I don't even know how do I do an operation that gets me up there where I could solve for that x? And the answer is we have a rule that does this, and it is one of our log rules that we looked at earlier. It is this one right here. This log rule right here is the one we're about to use. It's the thing that takes a power of an input and makes it the multiple of the logarithm, right? That allows us, if you look at it, that allows us to take an exponent up here and move it down in front of the logarithm so that it's no longer in that exponent. I just explained that part of the difficulty here is solving for a variable that occurs in the exponent. Well, if we can get it extracted from that exponent, it's going to be a lot easier to work with. Okay? So, how would we do that for this problem? So, I'm saying we're going to use a log property, but it's totally fair for you to look at this equation and go, but this equation doesn't have any logs in it. How am I supposed to use the log property if I don't even see a log? And that's a great comment. What we're about to do is take the log of both sides. So then the solution is, I'm going to take the logarithm of the left side and say that that equals the logarithm of the right side. Because if these two things are equal to each other, like our original equation says, then when I take the log of them, that should be equal to each other as well, right? Okay, well now we have a logarithm in our problem, and a logarithm was what we wanted so we could apply that power rule and bring the variable out of the exponent. So now I'm going to use that log property from right here, this one, to bring that exponent down in front. So I'm going to make this will become 3 times the log, oops, sorry, it will become x times log base 3 equals log 5. So see how I brought that exponent down in front using the power rule? Now, at this stage, I think people start to get a little confused because they're not used to the notation yet. Okay, they're still getting used to the notation, and we're used to solving for letters. When we have equations and we see a letter, we go, oh, I'm probably supposed to solve for that thing. Well, this problem has 4 letters in it. In fact, you could say it has 7, but 3 of them are repeated, right? But you're like, there's an X, there's an L, there's an O, there's a G. What am I trying to do here? What am I supposed to solve for? X is the variable we're solving for. These letters are just a shorthand notation for the function that is the logarithmic function. So these letters are not variables that we would be solving for. What this means is that log 3 is just a number, right? If we had 2x equal something, what would we do? We'd divide both sides by 2 to get rid of the 2. Well, here we have log 3 times x, so we're going to divide by the log 3 in order to figure out what that is, right? The logarithm is just a number, and it looks complicated the way it is here, but it's just some number, right? Let's take, in our calculator, let's take 3, take the log of it. It's just 0.477121254, this whole thing right here. So divide both sides by log 3. So x equals the fraction log 3 over log 5. right? And this is the exact answer for that equation. Now, you might look at it and go, well, I don't know what that is. That's fine. Then you can get out your calculator and you can see what it comes out to. And you can do your, you do 3 log divided by 5 log. You could do the whole thing there. So you can do it in a scientific calculator that has a log button. But this is the exact value. What you don't want to do is start putting it in the calculator early on in the problem. We always want to finish our problems with exact answers. And then sometimes we can convert them to decimals. But in this case, we don't even want to do that. Our final answer should be log 3 over log 5. That should be the equation that we're dealing with, okay? So that's how you do this kind of a problem. Let's see if we can get one that's slightly more complicated. Yeah, let's do this one because I know people get a little confused about this. So let's do this one. Okay, this one might look a little scary at first. This one might look a little scary because you're like, well, now we have variables on both sides. Man, okay. And then I've got, I guess that's the only thing that looks a little scary about this one. So what we want to recognize is that we still want to do the same thing. Sorry, I'm sort of getting confused here as far as like what I want to explain. Here's the problem. Let me just cut to the chase here. Here's the problem. People look at this and go, "Oh, 6 and 2. I can write 6 as 2." But remember what we're doing is we're writing 6 as a power of 2, not a multiple of 2. So this part, like remember that's what we did up here. We wrote 1/2 as a power of 2. We wrote 81 as a power of 3. People get confused when they see a problem like this and they start thinking about writing as a product of 2, right? A multiple of 2. But that's not how this works. You have to be able to write it as a power of 2. Can 6 be written as a power of 2? No. So don't try to use that first technique that we used up here where you would set the, you'd write both sides in terms of the same base and then you would set those exponents together. We can't do that. We have to treat this problem more like the one we did up here, like this one. So how would I do that? Well, what did we do here? We took the log of both sides. So let's do that again. We're going to take the logarithm of both sides here. Okay, so I took the logarithm of both sides. And now again, we always go, oh, there's variables in those exponents. We better try to get them out of there. So we're going to use the power rule to bring these powers down in front of the logarithm. So by doing that, I'm going to get x minus 3 times the log of 6 equals x times log base 2. Okay, so I just brought those exponents down in front. Notice that I wrote parentheses around the x minus 3. That's pretty important. Because notice if I write the line a little bit differently without the parentheses, notice that here only the 3 is multiplying the log 6. Whereas up here, the log 6 is multiplying both the 3 and the x. So it's really important that you remember to put those parentheses in there, or else you're going to end up with a mistake that's obviously going to wreck all your work, right? But it's an easy mistake to make because up here it didn't have parentheses around it. So how are you supposed to remember to put parentheses around it? You just practice this enough that you go, that's right, I better be careful right here. But the key is we wrote the exponents down in front. And you go, okay, well, now what am I supposed to do? Well, our goal is going to be to get all terms that contain an x on one side of the equation and all terms that do not contain an x on the other side of the equation. Well, in order to do this, what we first have to do is we have to do the distributive property right here. Right? We have to distribute that log 6 into the x and the 3. So when I do that, I get x log 6 minus 3 log 6 equals x log 2. Okay, so all we did was distributive property right here on this part. Nothing fancy, right? This is the same logarithm stuff, or the same distributive property that you used in, beginning algebra. Okay? So now at least we can start collecting terms. So I want all of my x terms, I'm going to put them on the left. All of my non-x terms, put them on the right. So I see one x term here is a term with an x in it. Here's a term with no x's. Here's a term with an x. So what I'm going to do is I'm going to take x log 6. I'm going to add 3 log 6 to both sides, and I'm going to subtract x log 2 from both sides. So minus x log 2 equals 3 log 6. Okay, if there's questions here, let me know. Okay, but what did I do? I added 3 log 6 to both sides. I subtracted x log 2. So what do we have? We have our x terms on the left, non-x terms on the right. Now remember, 3 log 6 is just a number. You can put that in a calculator and see what it's equal to. So what would the next step be? Well, notice we have 2 terms that have an x in it. Why don't I factor that x out, like a reverse distributive property? I'm going to factor that x out, and then we'll have only one x instead of 2, which makes it a little bit easier to solve for. So let's look at that. If I factor that x out, I'm going to get x times log 6 minus log 2 Okay, so if you see, all I did here was factor the x out, okay? Just factored the x out of there. Okay. Now, this looks confusing, but remember, everything in the parentheses is just some number. It's log 6 minus log 2. You could put that in your calculator, right? If we look up Wolfram alpha. And we can just do log 6 minus log 2. And it gives us, it's a number. It's approximately 1.0986122 and so on. So it's just some number. So we can go ahead and divide by it. So if we divide by both sides by that, we get x equals the fraction. Let's see, on the bottom we just have, no, on the top we have 3 log 6. And on the bottom we have this thing. Here. Right? 3 log 6 over log 6 minus log 2. And it's totally reasonable to look at that and go, I don't know what that number is. I don't recognize that number. And you won't, right? But you could put it in a calculator and you could figure out what it is. We could put it in Wolfram alpha and go 3 log 6 divided oops, divided by this. Whoops, I'm kind of covering up. But if we put it in Wolfram Alpha, we can see that number is about 4.8927 roughly. So at least we have an idea of what it is, right? But the exact value is 3 log 6 over log 6 minus log 2. That's the exact value that we're looking at. Okay. I'm going to take a quick break. I have to run to the bathroom, so I'll be back in like 2 minutes. Give me like 2 minutes, and then we'll look at some more examples of this. Feel free to ask questions while I'm gone. If you want to throw some questions into chat or anything like that, I'll take a look at that when I get back, okay? Just give me a couple minutes. Okay, so let's see. Here's something in chat here. Oh, there's a good question. So, comment here. I was wondering if you could explain plot and graphing log functions. Delta Math does not have a help video in this section. Okay, so I'm going to make a note of that questions because that's a good question. I don't have time with the time remaining. I don't have time to cover that. But what I'm going to do, let's see. In fact, do I have one? Let's double check over here. If we go, uh-oh, did my screen freeze? What's going on? Uh-oh. This is weird. So my window is giving me problems here. Can I pull this out? Let's see. If I pull that out, and then I think that's operating. Okay, let me close this window. It all froze, so I can't show you anything. So let me redo this. Let's see. Close that. And then I'm going to open a new window. And I will sign in. Oops, sorry. I'm trying to find room to put the stuff I'm trying to look at on here. Was it? Oh, right. So I'll sign in here. This is not good. I think I'm going to have to totally restart Firefox. The problem with that is that my YouTube stream screen is in Firefox. So sorry, everything's locking up here in my window here. And it's not working properly. So that one looks like it's working properly, but it's not letting me sign into anything. Okay, so here's what I'm going to say. I'm going to have to restart my browser here completely, which could disconnect the YouTube stream right now. If you're on Zoom, you'll be fine. But if you're watching the YouTube stream, you could get kicked off here in a minute. If you do, just give it a minute and then try to reconnect. Okay, because I'm going to try to reestablish that connection. There's something wrong with the Firefox browser, like got overloaded or something. So I'm going to have to restart that browser, and then I'm probably going to have to restart the connection for the stream. So if the stream dies, just give it 1 minute and then try to, just like you normally do, come back to the channel, try to get back into it, okay? So hopefully we don't lose everybody. Hopefully we still have 13 people in a minute. Let me see what I can do here. Let's close these all. And then restart. And if I'm fast enough, maybe. Nope. Looks like I'm going to have to do... So I think I'm going to have to do a full computer restart because it looks like that's not working. So this is going to take a minute. Let's just restart the whole computer.